All right, welcome students. And so we're going to cover Unit 1 study guide. And so we only have a few days left on this. So please make sure that you're following along and you're positively participating. No disruptions will be accepted. Please focus and learn so that you can get a proficient on the mouse phone. I would really appreciate it. Here we go. Unit 1, what you need to be able to know and be able to do. How to identify parts of a triangle, expression, triangle, goodness gracious. Things like the variables, the constants, the ones that have no variables on them, the terms separated by plus or minuses, coefficients, and factors. So when you get something like this, 32x squared minus 8x plus 4y minus 9, how many terms do we see? 1, 2, 3, 4 terms, right? How many variables? I see 2 variables. Constants. Constants are going to be the terms that have no variables and there's only one of them. Not 9, but negative 9. Okay. Factors of the first term. The first term are this one and 32. 32 can be broken down into 2 times 2 times 2 times 2 and times 2. 5 twos. Yeah, so the factor is going to be 2 raised to the 5th power times x squared can be broken down into x times x. All right, so about understanding is the things that you need to multiply together to get that number. All right, with that mindset, how many terms do we have on example B? 3 terms, right? How many constants do we have? Correct, only one of them, negative 7. Coefficients. Coefficients are going to be the numbers in front of the variables. So, exactly, this one is the 24. And there's another one right here, the negative 1. Not the negative 7. The negative 7 is a constant. It has no variable. Factors of the second term. The second term is this one. So that'd be negative 1 times x. Right? I had to name our polynomials. It's another standard that we had to know. The first name is the degree, that's the highest exponent. The last name is the number of terms. So hopefully this is review. Right, oh, standard form is when you write them in highest degree to lowest degree. Clear? And then more class and then classify them. So first we need to rewrite this because this middle term needs to go first. So it's 7x squared plus 3x minus 5x. Oh, and then these are like terms. Do y'all see that? 3 minus 5 is not 2, negative 2. All right, so we need to name this or classify it. Highest degree is exponent 2. Exponent 2 is called quadratics. And how many terms do we have? 2. So it'd be binomial. So it would be a quadratic binomial. I have paper here, and you should also have paper. I don't want to hear one complaint about not having enough room. You don't have enough room, take out a piece of paper or come and get a piece of paper. Keep your work neatly and organized so that when I do the check, it's all there, okay? 23. 23 is the only term, so it's going to be the first term and the last term and the only term. And it has no variable, so it's just a constant. I mean, if you want to be technical, it's a constant monomial. But if you're a constant, then it's understood that you're the only one there. So we usually just go by constant. All right, this one, is it in standard form? Correct, it is not. Well, first of all, these need to be combined because they're like terms, right? Anybody know what 2 plus a negative 1 is? Correct, 1. And then negative 2x plus 5. Can you classify it? Classify it. Let's go. First one to speak up wins. Correct. Quadratic trinomial. All right. The next one, is it in standard form? Okay. Which one should be the first term? 2x cubed, right? All right. Which one should be the next terms? Yes, x squared. Which one should be the next terms? But we have two of them. So in your calculator, you need to do -4 plus -3. And then make sure you include the constant. There you go. That's your polynomial in standard form. Now you need to name it. Exactly, because of the cubic and the fact that you have 4 terms, so it's a polynomial. The next thing you need to be able to do is add and subtract polynomials without making mistakes with the negative sign. Make sure you have that calculator ready if you don't understand the integer addition that we're doing. The first things you want to do is you want to get rid of your parentheses, which we don't have to do that if we have plus signs. But if we have a minus sign, we need to change everything inside the parentheses that follows that negative sign. And then afterwards, we need to combine like terms. So we're going to start off easy. We have parentheses, plus sign, parentheses. Clear? The fact that it's a plus sign means that we don't have to change anything. And so we can go straight to the end, which is just combine like terms, starting with the terms with the highest degree. So terms with the highest degree would be this one and that one. Very carefully in your calculator, what is 3? Add -7. -4x squared. All right, next term with the next highest degree would be this one and this one. Carefully in your calculator, let's go engage. -4, add 2. And then the constants. The milestone is not the time for you to be brave. Are we clear? This is the time for you to wimp out and use the calculator for even the simplest things so that we don't make a mistake. What is 8? Add -5. +3. All right, can you all classify it? All right, sorry, had to get the door. All right, this one, once again, is a plus sign. So this set of parentheses plus this set of parentheses, because of the plus sign, you don't have to change the signs. Chi, we're in the middle of the review. Combine starting with the terms with the highest degree. All right, so that's 7y squared plus 5y squared. Then you have 2y and -4y. And then you have the constants. All right, go ahead and combine them. Shh. Student that came in late. All right, did you combine them or did you just circle and underline what I did? Be independent, not a follower. Come on. Anyone? What is 7 add 5? Don't forget about the variable y squared. All right, what is 2 add negative 4? And the last one, the constants, negative 3 add 2. Please practice typing it in the calculator. The last thing you want to do is mess up on the basics. You're able to do complex problems, but then you mess up when you're adding integers, okay? Classify it. All right, first example with a minus sign in between the parentheses. Okay. Now this minus sign is kind of like we're distributing a negative 1. If you want to look at it the simple case, everything inside this parentheses is going to change signs. It's going to go to the opposite sign. So that 2x squared will become negative 2x squared, plus x will become minus x, and minus 6 will become plus 6. This is the only time that we're going to go over the basics in Unit 1. After this, we're going to assume that we know how to add, subtract, and combine like terms when we're doing the other units, okay? So I'm not going to rewrite the first one, but I am going to rewrite this. So it becomes minus 2x squared minus x and then plus 6. And just so I don't make a mistake, all of this is gone. So I'm dealing with this and I'm dealing with this. Okay, combine your like terms. Okay, what is 3 add negative 2? All right, what is negative 3 add negative 1? And negative 5 add positive 6. No, you don't. No, we already distributed the negative sign. So it's now technically a plus sign outside of this. Okay. All right, Chris, you're talking a lot in front of me. Thank you. All right, this one, same thing. When we distribute this negative sign, everything inside this set of parentheses is going to change signs. Clear? And so we're not touching the first one, but this right here becomes plus, and then inside this negative 2x squared becomes positive 2x squared. The 5x and the 3 become negative 5x and negative 3. Okay? And this is why I'm crossing this out. So now combine your like terms. All right, here we go. 4 add 2 is 6x squared. 2 add negative 5 is negative 3x. And negative 7 add negative 3 should be negative 10. And yeah, quadratic trinomial. Now the next two are very interesting problems because they're going to use number sense. All right, I have an equal sign, and they want us to find the values of m and n. All right, this is already simplified. But over here we have plus, and we need to combine these parentheses to simplify it as well. Now looking for like terms, I notice that this one has an x squared, and this also has an x squared. And there's a plus sign, so we're not changing signs, okay? So this becomes 2 plus m. No, they're not like terms. 2 plus m is just 2 plus m. They're not like terms, so you cannot combine them. No. What arrow? That's an x. All right, this 3x and minus nx. They both have a single x, so I'm going to combine the coefficients, right? So what is 3 add negative n? 3 add negative n, right? Number sense. If we can do this with regular integers, we can do this with variables. Now the constants are going to go easy on us because that's a negative 8 add a positive 4. Yes, and I'm out of room, so I'm not going to rewrite that part, okay? But we know it equals whatever that is after the equal sign, okay? So what does this tell us? This tells us that the x squared term is equal to the x squared term. The linear term is equal to the linear term, and the constant is equal to the constant, right? So I'm going to work over here on the side. So this means that 2 plus m x squared is equal to 5x squared, right? So that means that 2 plus m is equal to 5, right? If I cross out the x squareds. All right, so just number sense, 2 plus what equals 5, right? M equals 3. Okay. Or you can subtract 2 on both sides, you get m equals 3. Okay. Now the other one, 3 minus n is equal to the negative 8. All right, if you can't quite see it, then let's just use our skills. If there's positive 3, we need to subtract 3 on both sides. Right? Because it's positive, the opposite would be negative 3. Negative n equals negative 11. And since they're both negatives, that means that they're both positives, right? Say it louder because I can't hear you. Why did I turn the 3 into negative 3? Because I'm subtracting 3 from both sides. If I didn't do that, then they wouldn't cancel. All right, this one, I'm going to use additional paper because it's not going to fit. And once again, I don't want to hear any crying that you don't have enough space. I still expect you to solve the problem. Okay? So it's a very similar problem. This side is already simplified, but this one is not. And this one has a minus sign. See? So we need to be very careful when doing this problem. I'm just going to copy it. So we have mx squared minus 6x plus 3 minus. Okay? All right, so this one is 3f. Clear? All right, so the first thing you need to do is we need to get rid of that negative sign. That means that everything inside the parentheses is going to change signs, right? That'll become a plus sign, but everything inside will change signs. Okay, find a seat. Is the bell about to ring? Okay, so we'll continue after lunch. As you all know, lunch is sacred. Wait, Pelham students, come and see me. All right, let's continue. I lost the paper that I was on. Oh my gosh. Anyways, did I finish the problem? All right, moving on. All right, you also have to be able to multiply polynomials. Now, here's the thing about multiplying polynomials. Okay, you're going to multiply the coefficients. I know, but I can't find it. I can't find the paper that I was working on, so. Okay, and then you need to add the exponents. Okay, so please don't make that mistake when multiplying. So this one is a very straightforward multiplication problem. We set up the model. The 5 is positive, so I don't really bother putting a positive sign. But the 2, this is a negative 2, so I do put that in there, okay? And now this, once again, the difference, we talked about this extensively in class. X times x is x squared. X plus x is 2x. So please do not get confused when you're multiplying or when you're adding variables, or basically like terms. Okay. All right, so x times x is going to give you x squared. This will be negative 2x, 5x. And here when you multiply, the 5 is positive, but the 2 is negative, so it's negative 10. After you're done filling in the boxes, you're done multiplying. You're done multiplying. So now what you're going to do is you're going to combine like terms. Combining like terms means adding them. So this grid right here in the center forms a plus sign to remind you that you're doing 5 plus negative 2. All right, so your answer is going to be x squared plus 3x minus 10. All right, and the 3x came from 5x plus negative 2x. All right, so what does this mean? This means x minus 5 times x minus 5. All right, set up your grid, multiply your mini products. Each of these is a mini multiplication. All right, x times x, negative 5 times x, negative 5x. Same thing here. Now, here's the thing where please remember to use the calculator even for the simple stuff on the milestone. This is not the time to be brave with our math facts. Negative 5 times negative 5. They're both negative, so the product is going to be positive. And once again, this is not the time to be brave with our math facts. Negative 5 plus negative 5 is not 0. Exactly. It's product means to multiply. Okay. Chris, please focus. Christopher, please focus. As I'm working here, I really don't want to be disrupted in this video that I'm making for all of the classes. This is negative 12x because I'm multiplying those two. This is 2x times the 3. And then negative 4 times negative 3 is negative 12. It is. Mhm. Without disruption, please come back in, okay? All right, once again, this is not the time to be brave. Are we clear? Using your calculator, add those two coefficients to get the correct sum. So what's negative 12 plus 6? There you go, negative 6x. And it's minus 12. All right, so please don't wait for me. Go ahead and start multiplying the mini products and then combining them. All right, x times x, x squared. X times 3, 3x. Negative 3 times x, negative 3x. Yes, negative 3 times positive 3 will give you a negative 9. Okay. I'm going to say this again. This is not the time to get brave with your math facts. Use the calculator. Negative 3 plus positive 3. What do you get? 0. They cancel out, right? So your answer is just x squared minus 9. Opposite pairs. One's positive, one's negative. All right. Here's where addition and multiplication come in to play. Nobody's going to tell you to add. Nobody's going to tell you to multiply on the milestone. You need to know that perimeter means that you fill in the missing sides and you add all of the sides. So the biggest mistake that students make is that they only take the two that are given. For perimeter, you need all 4 sides. So how much is this side? All right, and this bottom side? There we go. And now you just combine all the like terms. So every single one of these has terms with an x. So you need to add them. X plus 2x plus x plus 2x. How many x's you got? Right, correct. 6x. Now you got to do the constants. Please give everybody an opportunity. Let's go. Take your opportunity. All right, what'd you get? Exactly. All the constants are going to add up to a positive 4. So that's your perimeter. It's a simple concept, but if you mess it up by excluding the missing sides, then you'll get it wrong, okay? Now, area depends on the shape. So use the area formula for the respective figure. And I'm looking at the formula sheet somewhere. I'm not, I guess. Wait, I got it right here. Yep, the shapes are not here. So how to find the area of a rectangle, you need to know. How to find the area of a triangle, you need to know. And of course, the rectangle and a square are basically the same thing, okay? So for this one, we'll say this one is the length and this one is the width. All right, go ahead and multiply while I work on not choking over here. Kai Davis, another 5 minutes. Multiply. You're safe, Malachi. Don't worry about it. I'm still staring at him. Still staring. I don't know why. All right. What goes inside these little boxes? This one. There you go. And using the calculator, the milestone is not a time for you to be brave. Both of you are going to spend 5 minutes outside. You and him. All right. Now, this is the milestone's favorite problem because it includes addition, subtraction, and multiplication. Are we clear? All in one big fat problem. All they want is the area of the shaded region. That means it excludes this little box right here in the center. So how do we do this? Well, what you need to do is you need to get the area of the entire bigger rectangle, right? Including the center, the whole area. Then we need to subtract the area of this smaller section. When we do that, that'll leave us with the remaining shaded area. Got it? You're gonna need paper for this. And this time I'm not losing my paper, so here we go. All right, so here's the concept. It's gonna be the big square minus the small inside square. And that's gonna give us the area of the shaded region. Oh, I'm sorry, area of the big square, area of the small square. And when we subtract out the small square, we'll get the area of the shaded region only. Okay. So, all right, do we agree that the big square is 4x plus 2 times 4x plus 2? Okay. Okay. Do we agree that the small square is x minus 1 times x minus 1? All right. So now I'm going to fill in the boxes. Are y'all caught up, ready to multiply, or are you still drawing squares? All right, if you're done with the boxes, start multiplying. All right, so here we go. 4x times 4x, 16x squared. 4x times 2, 8x. 2 times 4x, 8x. 2 times 2. All right, once again, 8x plus 8x is going to be 16x. Clear? All right, so this one becomes 16x squared plus 16 regular x plus 4. All right. No need to just copy. You have the information right in front of you. Work with it. Work the math. Don't just copy. Copying is just drone. Multiply, add, work it out to stay awake. Now this one, x times x will give you x squared. X times negative 1 is negative x. This one is also negative x. Now, negative 1 times a negative 1, because they're both negatives, is going to become a positive 1. Right. Now, notice how I'm going to put this in parentheses. X squared minus 2x plus 1. Now we have to follow the rules of subtraction. Clear? And that says that we need to distribute that negative sign. That means everything inside this second set of parentheses is going to become the opposite sign. So this will become minus x squared plus 2x and then minus 1. Oops, my bad. All right, so this will become minus x squared minus 2x minus 1. Now it's time for like terms. But I know you're probably a little behind in the writing, so I'm going to hold off, okay? So catch up. Don't blink if necessary. In fact, don't even breathe, just copy. So you might become oxygen deprived, but it's okay. Purple is in. They got it. Everybody else is just looking at me weird right now. All right. Anybody, what is 16 add negative 1? There we go. 15x squared. All right. Now the single x's. Ooh, they're both positives. Nice and easy. What is 16 plus 2? You'll see? Now for this, I'm going to use a circle to kind of tell them apart. Now what is 4 add negative 1? And there you go. All right, we'll do the next two problems tomorrow. All right, flip the page. All right, the next standard that we did in this unit was radicals. Everybody say hip, hip, hooray. Now, the first part of the milestone is no calculator. Are we clear? So you have about 20 questions that are, maybe like 15 questions that are not calculator. So that is why, even though some things you can do with the calculator, there are some questions that they're going to ask you to solve that don't require a calculator, that don't necessarily need a calculator. All right, simplifying radicals. If the problem contains a perfect square, which means that you should know your perfect squares, and if you don't, here I go. 9, 16, 25, 36, 49, 64, 8, 9, 81, 81 and 91, 100, 120. I was gonna put 125. I'm sorry, 121. 169. 11. No, 144. 169. 196. 225. And they've been known to use the other ones that are higher, all the way up to 20. But these you should recognize. Are we clear? Perfect squares. I think I've said this many, many times last semester, okay? So when you look at this problem, 36, you know that that's 6 times 6, right? And remember, couples go out as 1. So it's going to come out as 6 times the square root of 1. Square root of 1 is just 1, which is why this whole thing is just 6. Right? The two sixes come out as a single 6, which means a 1 is left inside the radical. The square root of 1 is just 1. So just, or you could just be like, it's a perfect square. The square root of 36 is 6. Is 60 a perfect square? No. So we need to find what perfect square lurks inside of 60. So obviously it's going to be a number less than 60. Are we clear? And no. 60 divided by 2 is what? 30? It's not good. What's 30? 3 times 10, 15 times 2. 15 times 2 will lead us to the answer faster. All right, and we already have that too, so there you go. There's the pair. 15 is just 5 times 3, right? So even if we break this down, there are no perfect squares there. So it's 4 times 15. So negative 3 is the square root of 4 times the square root of 15. Right? 15 times 4. It's going to give you the 60. All right, so that's negative 3 times 2. Now, can we break down 15? It's just a 5 and a 3. There are no pairs. So it's just going to stay as the square root of 15. And of course, all right, with variables, even exponents, divide by 2. Okay, even exponents, divide by 2. Do we agree that 4 and 10 are even exponents? Yes, yes, we do, Ms. Medina. What is 54? 54 is not a perfect square, but which of these is a factor of 54? What are factors of 54? Start thinking math facts. Make your elementary school teachers proud. Let's go. 9 times what is 54? 9 times 6 is 54, okay? Good. And why am I so caught up with 9? Because 9 is a perfect square. Are we clear? All right, so here we go. So the 54 is going to break down into the square root of 9 times the square root of 6, clear? And the square root of a to the 4th and the square root of b to the 10. And when you get really good at it, you skip these steps. But this is what's going on. I need to write down because it's a review. What's the square root of 9? 3. Square root of 6. 6 is 2 times 3, so there's no repeats, right? Focus on the milestone and us getting proficient, not the door. Cameron, can you lower the window curtain, please? All right, now this one is an even exponent, clear? What's 4 divided by 2? How is 4 divided by 2? 8. There you go. Radical is gone. Are we clear? What is 10 divided by 2? No, Nicholas is not 60. I'm going to say the last name too in the video. Hicks? Nicholas Hicks is not 60. Please don't make funny jokes, okay? All right, Nick, how do I simplify this? This, all of those 3 are your coefficients, okay? And we put the radical 6 at the end. I don't know why, but technically speaking, all of them are coefficients. It's just a big old expression here. Even exponents divide by 2. Odd exponents. Subtract 1, divide by 2. In simple terms. Lord, this is already outside, so we're going to leave the 3x. Oh, 16 is a perfect square. We don't have to worry about that. But x to the 5th. Y'all see how 5 is odd? Subtract 1, what do you get? So x to the 4th. And then, hold on, let's just subtract 1. We need 5, right? Subtracting 1 gives us the even exponent, but we have that 1 that we took out, right? Yes or no? Okay, we can just get rid of it, okay? And then y squared is already even. So this is how your brain should be compartmentalizing. Right, ready to clean it up? So 3x is just 3x. Square root of 16 is 4. This is even. What's 4 divided by 2? There you go. This is odd, so we can do nothing. But this one is even, so we can divide by 2. What's 2 divided by 2? Okay. Ooh, Lord, Lord, Lord. So you have 3x. Oh, sorry, my bad. What's 3 times 4? What's x times x squared? Then we have the y, and then the square root of x. Okay. Here's another little trick that you guys tend to forget is that when you multiply a radical by itself, the radical goes away. So if I say radical 3 times radical 3, that just becomes 3. Why? Because what's 3 times 3? 9. And what's the square root of 9? 3. If I say radical 2 times radical 2, that just becomes 2. Why? Because 2 times 2 is 4. And what's the square root of 4? 2. If I say radical 10 times radical 10, what does that become? If I say radical 61 times radical 61, what does that become? Guys, are we seeing the pattern or not? 61. If I say the square root of 13 times the square root of 13, what does that become? One person? Two people? Fine. I'm not. 5 times 2 is? And radical 6 times radical 6 is just? So that just gives you 60. All right, negative 2 times 4. Radical 3x times radical 3x. All right, so that just gives you all right, we cannot do that here because this is x to the third and this is x to the fourth. Are we clear? Clear, clear, clear? So 2 times 2 is? And this is the square root of 7? Even or odd? Deanna, even or odd? Odd, right? Because 7 is odd? Yes. All right, so we're going to subtract 1 and then divide by 2. Clear? What's 7 minus 1? So this becomes x to the 6 times x. Clear? Now, even exponent. What's 6 divided by 2? So this is 4x to the 3 square root of x. Oh, lordy lord. What is this? All right, which ones are inside and which ones are outside? 3 and 4 are outside. This one and this one. So what's 3 times 4? 12. What's 18 times 3? I'll make my elementary school teacher proud. 3 times 8, 24. 3 times 1 is 3 plus 2 is? 54 is 9 times? 54 is 9 times 6, yes or no? Beautiful. All right, so 9, 6. Now the variables, I have a squared and a over here. How many a's is that? I have a b and b cubed here. So how many b's is that? Good job, guys. Remember, you're adding the exponents. I'm glad that we remember that. Are you all caught up? I'm going to have to do this in 2 steps. What's the square root of 9? So 12 times 3. All right. B to the fourth. B to the fourth is an even exponent, right? What's 4 divided by 2? All right, so it's going to come out as a B squared. Ah, 12 times 3. All right, this is an odd exponent. Yes or no, Deanna? This is an odd exponent, right? All right, so we just subtract 1, right? What's 3 minus 1? All right, last thing to take out, this even exponent, a squared. What's 2 divided by 2? 1, so it's going to come out as a single a. Ooh, Lord have mercy. You really have to, really have to know your math facts when simplifying stuff like this. And it's not something that one example is going to do this for you. All right, there is no math way, chop way, easy way, cheap way on the milestone. You either know how to do it or you don't. So when I give you practice for this, please don't use math way and chop way and cheat way and all that other stuff, okay? Suffer by hand, learn your math. All right, when you're adding and subtracting radicals, you need to be like terms. You need to simplify all your radicals first. Then add and subtract your like radicals. Like radicals are like this. Radical 2 plus radical 2 is 2 radical 2. Because you got a 1 here and you got a 1 there. 3 radical 2 plus radical 2 is 4 radical 2. Like terms, are we clear? Add the coefficients, keep the radicals. Treat the radicals like variables. All right, are these like terms? Yes or no? This is a 3 and this is a 1. All right, are these like terms? Why are they like terms? Why are they like terms? Yes and no. You said the 7 and the 7. You have to say radical 7, radical 7. They both have a radical 7. So then this is 8 minus 3, radical 7. We following? And what's 8 minus 3, Nick? Thank you, Nick. Now, are these like terms, Gabby? Yes, are these two like terms? No, they're not because they don't have the same radical. Did you catch up? Why were we able to add these two? Okay, yes, they're not like terms. But the first thing that we have to do is simplify all the radicals. Now, radical 6, 6 is just 2 times 3, and we can't break it down anymore, right? So there's no way to simplify 6. But 24, can we simplify 24? 6 times 4, and then 4 is a perfect square, which is 2 times 3. So we can't do anything with the 6, right? But we can reduce it to the 4. So all right, so I rewrote the 24 as 4 times 6. Follow quickly. Do we agree the square root of 4 is 2? Now, I rewrote 3 times 2 as 6. Now, Gabby, are they like terms and why? They both have the same radical 6, right? So now we focus on the coefficients. This is a 4, this is a -6. And what's 4 minus 6? So -2 radical 6. And yes, your calculator can do this. Unfortunately, if they're going to ask you these standards, these are the ones that they're going to ask you when you cannot use the calculator. I'm not sure who you're referring to as girl, but I know that I am Miss Medina. Okay. All right. Now, are these like terms? Are these like terms? No, right? So we need to break it down. 20. How are we going to break this down? 5 times 4. Now 4 is a perfect square, but 5 is just 5 times 1, so we can do nothing with that, okay? So the square root of 20 is the square root of that, and it's just going to become 2 radical 5. Okay? All right. 60. How are we breaking down 60? 5 times 12? Okay, but those are not perfect squares, so 12. How do we break down 12? How about 4 times 3? Sounds good. There's the 5, here's the 4, and there's the 3. Right? Yes or no? Okay, so the square root of 60, notice how I'm putting that, the radical there, is going to be the square root of those 3 numbers. What's the square root of 4? So then this becomes 2 radical, what's 5 times 3? Oh, and then radical 5 by itself. All right. This is just the radical 20. Are we clear? And there's a 3 here. So 3 times 2 times radical 5. That's this first term. Yes or no? Because my hand is starting to hurt because it's like twisted sideways. Yeah? Oh, okay. Now this one is a 2 with the radical 60. So plus the 2. And the radical 60, we said was 2 radical 15. Clear? Now this one we don't have to simplify. I think I forgot to say that, but it's pretty obvious. It just says radical 5. Now multiply. What's 3 times 2? 2 times 2? All right. How many terms do you have? 3 terms. Out of those 3 terms, are they all like terms or only some of them like terms? Which ones? Okay, so now you know that they're like terms because they both have a radical 5. So now focus on your coefficients. This is a positive 6 and that's a negative 6. What is 6 add negative 6? 0. 12. 6 plus a negative 6. 0. They cancel out, right? Because they're opposite signs. Hey, 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 be nice and nobody needs to insult anybody. Okay. Isn't this everybody's favorite standard? No, it wasn't anybody's favorite standard. Neither is Rn3, which is the rationals and irrationals. Anything that needs to be simplified here? Does radical 2 need to be simplified? Does radical 2 need to be simplified? Yes or no? No, because radical 2 is as simple as you get, right? What about radical 10? Can you simplify radical 10? 10 can become 5 times 2, but are there any perfect squares there? So can we simplify 10? Nope. Correct. Nope. And can radical 5 be simplified? Okay. So we have no choice but to multiply. Why am I using a distributive property here? And there's a minus sign here, right? So, y'all remember 5 is going to get multiplied with which number? So the 3. And the 2 is going to get multiplied with the 10. So 5 times 3 is 15. 2 times 10 is 20. Okay. Now, ignoring this one, the 5 is going to get multiplied with which one over here? With the negative 2. 5 times negative 2 is negative 10. And then 2 times 5 is radical 10. Oh, Lord. Are these like terms, Gabby? Why not? Exactly. One is 10 and the other one is 20. Can we simplify these? Let's think about factors. 20. What two numbers multiply to 20? 5 times 5 is not 20. Yes, 4 times 5, and 4 is a perfect square, right? What about 10? Can we break down 10? 5 and 2, are these perfect squares? No. Okay. So radical 20 is going to become this. And the square root of 4 is just 2 radical 5. The radical 20 to radical 5. The 15 is already there, okay? Anybody? 15 times 2. Gabby, are you there? Are these like terms? No. And all that work that we did? No. They're not like terms, so we can't even combine them. But it is simplified, which is required. Are we clear? You think we can make it with these two in the video and just finish off radicals today? Yes? I hear us really. Okay, so here we go. Are these like terms, Gabby? Why not? Because why? Is the inside of the radical sign the same on both of them? No, they're not like terms. Clear? Clear? Okay, 12. Is there a factor of 12 that's a perfect square? 4 times 3. Right? So if we take the square root, this becomes 2 radical 3. You see the 12 is 4 times 3, right? So then it becomes 2 radical 3 because the square root of 4 is 2. Now the 27, is there a factor of 27 that's a perfect square? I'm thinking 9. 9 times 3. All right, so now watch. I'm going to wrap them both in radical signs, right? Now watch this. What's the square root of 9? So this becomes 3 radical 3. This stuff is a lot easier than last time, right? No? Not easy at all? The last time was not easy. If it was easy, I wouldn't have to review the standard like 50 times last semester. Okay, now we're going to plug stuff in to simplify this. Clear? For the radical 12, so this is going to become 2 radical 3w. And this one is going to become 3 radical 3w. Okay, Gabby, are these like terms? Why? They both have what? What is that number? 3w. Okay, so now combine your coefficients. What's 2 plus 3? So it's going to be 5 3w. All right, we're finishing this up. Yes, we are. 4 times what? 4 times 3? What is radical 2x times radical 2x? Stop it. What did I just say? Radical 3 times radical 3 is just 3. Radical 5x times radical 5x is x. So radical 2x times radical 2x is just 2x. The same radical by itself squares itself, and then you take the square root and you're left with just the base, okay? Now again, this one. What's 4 times negative 2? Oh, this one we can't do anything. Just square root of what's the inside times the inside. 2 times 5, 10. And here's an x, and here's an x to the 4th. Mental calculators. 12 times 2. So you see what I did to the x to the 5th? Why, Deanna? Because the exponent is odd, right? The exponent is odd, so that's why we subtract one, make one even, the other one odd. You, please stop bothering your peer. All right. X to the 4th is even. What's 4 divided by 2? 2. So this comes out as x squared. And I really think that's it because I don't think those are like terms. So in this video, we went over parts of the expression, naming polynomials, adding and subtracting them, multiplying them, area and perimeter problems, and then radicals, simplifying them with and without variables, even and odd exponents, and multiplying. It's been a pleasure.